What exactly is a knowledge graph? You may have heard of people say that Google uses knowledge graph for rendering search results very fast. Basically, a knowledge graph is a structured way to represent data, just like tables. Tables are a form of structured data set. However, knowledge graphs allow you to represent data sets with more complex relationships, which you see in real world. So a knowledge graph consists of these entities called as nodes, and the nodes may be connected through edges. Nodes themselves will have properties, and the edges may be directional or non-directional. And the great thing about these graphs is that it can be represented mathematically also using these adjacency matrices, which later can be used as input into convolutional neural networks like graph convolutional neural networks if you want to make predictions later. So knowledge graphs have significant advantages compared to tables. So in tables, you have fixed number of columns where each column represents a feature, and the number of rows can be any number because as many number of data you will have that many number of rows. In knowledge graphs, however, you construct edges between nodes to explicitly show the relationship, meaning the structure of the data is very flexible. You are not saying that only these features are allowed. You may have features if those features are correlated with, let's say, a person. So to give an example, here, consider this knowledge graph where you have the name of scientist, Einstein, and then here name of a country, Germany, name of theory, name of the concept, relativity, and whether it's a theory or not. So these are the nodes. Now edges say if Einstein and relativity are connected, it's an edge that signifies discovered. If Einstein and Germany are related, it's an edge that signifies born. So this kind of representation of knowledge is very useful for large concept models, which are rising in prominence compared to large language models. So it's a very reasoning friendly way of representing data. So let's say now we have a question, find all those scientists who collaborated with some other scientist who discovered a particular theory related to a particular phenomenon, and also somebody who did their research in a particular country, France or Germany. If such a search needs to be done in table, we will first need a list of scientists. Maybe the first column could be the scientist's name. Second column could be a set of multiple sub-columns with the list of discoveries. Third column could again be divided into multiple sub-columns with a set of people whom they collaborated with. And either we will need a very complex giant table, or we will need a collection of multiple tables, one for scientists, one for discoveries, one for collaborations, one for the type of discovery, whether it's a theory or whether it's something else, then list of countries and the corresponding scientists. So we will either need multiple tables or we will need giant complex tables. On the other hand, if the same data is represented using graphs in nodes and edges, we can perform something called as graph walk, where we start from nodes of the type scientist, because the first question is find all the scientists who did something, right? So start from all the nodes that are scientists and then traverse along the edge, which says collaborated with. So basically you can perform something called as graph walk, which will be very efficient in this case compared to having multiple set of complex tables. So knowledge graph is a very superior way of representing complex data that also explicitly captures the relationship between nodes